Hi, welcome back to my channel. Let's compare data warehouse, data lake, data lakehouse today. We will take a look at the reference architecture from AWS, GCP, Azure, Databricks, and Snowflake during our comparison. Data warehouses incepted in the late 1980s. Enterprise warehouses were built for business intelligence, BI applications, and reporting purpose. Data warehouse technology continued to evolve till now. The data warehouse has appeared on the public cloud since 2011. I compared three popular data warehouses, AWS Redshift, GCP BigQuery, and Snowflake. Their architecture, features, user cases, and differences. AWS Redshift and Snowflake use the columnar storage and MPP architecture. GCP BigQuery leverages Google's Borg, the large-scale cluster management system, and Dremel, the execution engine. You can take a look at that video for the details. Data warehouse is highly organized to easily access and analyze relevant data, but usually linked with vendor locking. For example, you select the data warehouse from AWS, GCP, Azure, or Snowflake to build multiple warehouses on the public cloud. Then the structured data is integrated into the traditional enterprise warehouse from external sources using the ETLs. But the data warehouse have the challenge to handle unstructured data, semi-structured data, and data with a high variety, velocity, and volume. 3 V's or 4 V's include the veracity. When the big data and MLAR become popular, the commercial vendors historically offer the parallel database management systems for the big data beginning in the 1990s, but it didn't provide the most cost-efficient solution, and data warehouses are not suited for the MLAI workloads and big data use cases. To resolve the challenges on big data and MLAI, data lakes emerged around the 2010s to handle raw data in a variety of formats on the cheap storage for data science and machine learning. A data lake stores the data in its natural raw format. It seems to have resolved the challenges on any streaming and complex data processing with a cheap cost than in the data warehouse. However, it's brought another challenges since the data is raw. It still needed to be queried and prepared for the analytics. Data lakes don't support transactions, do not enforce data quality, it lacks consistency, isolation, and requires building complex pipelines. So if the data lake didn't design well, it will become a data swamp. So we can see the big difference between data warehouse and data lake is the data in the warehouse is rigid and normalized. It is well structured, making it easily readable, while the data in the data lake is raw, loosely bounded, and decoupled. We lose rigidity and ACID compliance that make it difficult to mix appendants and reads and bench and streaming jobs all together. So in many cases, leading to the loss of many of the benefits of data warehouses. So can we combine data warehouse and data lake together to have both best features? The answer is yes. So the data lakehouse concept was evolving from 2017. The leading pioneers in this concept are Databricks and Snowflake, that we will take a look at their architecture later. Data Lakehouse is a new open system design architecture to combine the best elements of data lakes and data warehouses. It enables agility, cost efficiency, and scale data management and ACID transitions to support both BI and ML AI on all enterprise data. Now let's take a look at the architecture diagram from Databricks to illustrate the difference on these three systems. The left one is data warehouse architecture, the first generation platform that structures the data through the ETL into a data warehouse, then consumed by the BI and reports applications. The middle diagram is the current two-tier architecture on the data lake. All kinds of raw data stored in the data lake built with different data pipelines for ML AI workloads. Before Data Lakehouse, a common approach was to use multiple systems, a data lake, several data warehouses, and other specialized systems such as streaming, time series, graph, and image data, databases, and data mesh. This kind of design introduced the complexity, silos, and performance delays among the different systems. That's why we come to the right diagram. The right diagram is a design of a new Lakehouse model that combines a data warehouse and a data lake with a metadata and a governance layer to support both BI and AI. I will show you some reference architectures of Data Lakehouse. The first one is from AWS. You can go to AWS Modern Data Architecture page to get more details. There are typically 5 layers that make up a data lakehouse. Ingestion layer, data is pulled from different sources and delivered to the storage layer. In the storage layer, various kinds of data, structured, semi-structured, and unstructured data are kept in a cost-effective object store such as Amazon S3 and the data warehouse, AWS Redshift, and the two of them with native integration between the S3 and Redshift. A unified catalog that provides metadata about all objects in the data lakehouse, the storage, and enables data indexing, quality enforcement, and ACID transactions, among other features. The catalog layer is the defining element of the data lakehouse. Processing layer allows the user to understand what data is required for a particular use case and how to retrieve it. Then the last one is the consumption layer with the business tools and applications that leverage the processed data for analytics, BI, and AI purpose. The one with AWS native services for the 5-layer data lakehouse architecture, you can use this concept to replace some AWS services with the services or the system you preferred. For example, instead of Kinesis, you can use Kafka. Instead of Redshift, you could use Snowflake. Instead of AWS BI AI tools, you can use any commercial BI AI tools. Now, this architecture is from GCP Big Lake, which GCP just GA'd on the July 2022 and announced it in the GCP Next 2022. It's follow the same concept data lakehouse using the very similar 5-layer architecture. I like this architecture is because one, they are using the Apache Iceberg to support open file and table format. Well, you can use the Apache Iceberg within the AWS too. The second is they using the Dataplex, the enterprise data fabric, to manage data at a scale. I mentioned the Dataplex in the video of hot topics in the cloud computing 2022 video, so you can take a look over there. This is just the same concept. Instead of using AWS native services, using the GCP native services, you can also see that these support the data storage in either GCP storage, or you can using the AWS S3. This architecture is on the Azure Databricks along with Azure Data Lake Storage, and the Delta Lake built the Lakehouse architecture in the Azure. Of course, you can leverage the Databricks on the AWS and GCP to build a Lakehouse too. If your current data, majority of the data are unstructured, semi-structured data, and focus more on the ML AI workloads, then I suggest you take a look at the Databricks. If your current data is structured data in a data and most of them in the data warehouse, then take a look at the Snowflake. I will go through the Snowflake next. In this architecture, it leverages open transitional storage with Azure Delta Lake Storage and the Delta Lake to accommodate the data of all types, size, and speed. Delta Lake is a simple and open file format based on the packet that can be stored in the Azure Data Lake Storage. It supports ACID transactions, time travel, schema evolution enforcement, and streaming as a source and async. Then you're using the Azure Databricks as the fundamental computer layer that supports all of the core Lakehouse use cases, including the curating the data lake, for example, the ETL and the streaming processing, data science, machine learning, and SQL analytics on the data lake. The last one is the integration of the other services and tools between the curated data lake and the foundational computer layer. This is the last reference architecture we're going to take a look today. This is from Snowflake. Instead, the company builds either a data warehouse working in the parallel with its data lake, or data warehouse embedded in the data lake to serve the data for business intelligence and AI/ML. Snowflake Data Cloud Platform provides as a single data lakehouse platform. The architecture supports key features of lakehouse architectures like the others we just mentioned. Use the commercial ones such as Databricks or the Snowflake will save some of your build time and less effort on the administration. Now let's summarize today's video. We can either build a file-composed layer of the data lakehouse on the public cloud, or leverage Snowflake or Databricks on the AWS, GCP, or Azure. The key features of data lakehouse should be able to support for diverse data types and workloads, support for ACID transactions and end-to-end streaming, support open file and table formats, support schema enforcement and governance, decouple storage from compute, and also the last one, to support security and access control. I also provide this table as a cheat sheet of the difference among the data warehouse, data lake, and the data lakehouse for your reference. Thanks for watching, and as always, subscribe to my channel for more great cloud computing learning tips. See you next time.